Welcome to the Bible and Science. This is Dave Prentice. I'm a retired public high school teacher, certified in all branches of science and math. I've also taught on the Bible and science for many years, both in the U.S. and on many overseas mission trips. This is episode 19 of the Bible and Science. I'm going to continue what I started last time, talking about the question of how could light get here from distant stars in only a few days. This is part 2. And I promise you, I'm not going to prove it. I'm going to give you some possible explanations that I think are reasonable. Okay, let's go back to the idea about how light travels in deep space. We don't know how it travels. Sound and pressure waves require a medium such as air in order to propagate. While the only place we can measure the speed of light, which is not a sound or a pressure wave, the only place we can measure it is right here on Earth. And we found it moves slower in a dense medium, such as water, faster in a vacuum. Well, in space, what's light traveling on? Well, is it a wave or is it a particle? Yes, it's a wave or it's a particle, depending upon what kind of experiments you're doing. So we assume that light travels at the same speed throughout space. What if there's a medium we're overlooking, such as electromagnetic or gravitational fields? In that case, it would stand to reason that light could move at different speeds where there's a different field strength. In the past, there's been no way to test the speed of light in deep space, but something that may give us a clue that it's not constant is called the Pioneer anomaly. Going back over this from last time. Back in the early 1970s, NASA launched twin spacecraft known as Pioneer 10 and Pioneer 11 in opposite directions. As they went farther and farther from the Earth, it was a strange thing. They've long since left the solar system now, but as they went farther and farther from the Earth, the scientists were puzzled by the fact when they sent a radio signal out to the Pioneers and they bounced back, it took less time than was expected. Well, there were some scientists that believed that the spacecraft were slowing down because of invisible matter, some sort of dark matter, and this is called anisotropic radiation pressure. But here's an alternative I want to propose to you. Suppose light travels faster as it moves farther away from the sun. It's gaining gravitational potential energy with respect to the sun, with respect to the center of the universe. What? The universe has a center? I believe so, and I'm going to get into that shortly. That would lead to an anomaly where the speed didn't seem to be the same. So we're dealing with the question of how can we see light from stars that are billions of light years away if the Earth is young, if the creation account is correct? Well, as I've mentioned before, we don't know exactly how big the universe is. It certainly is huge, but we calculate it based on a series of assumptions. Regardless, how could light get here in only a few thousand years, even if it's only a few million light years across? Well, there are several possible answers. We talked about this idea of light paths from the stars, the idea that space could be curved, and also that the speed of light may have been much faster in the past, and light may travel faster in deep space rather than close to Earth. But now I want to spend a little time on gravitational time dilation. Gravitational time dilation, that means time can be stretched out. What does that have to do with creation? The Bible tells us over and over that space was stretched out. Job, Isaiah, Jeremiah, Zechariah, Psalms tell us at some point in the past, God stretched out the heavens. And then also the Bible tells us in Genesis chapter 1, verses 14 through 19, that the light from the heavenly bodies first became visible on earth on day 4 of the creation week. How could it get here within 4 days? That's impossible. Well, it may not be impossible. Remember, this is done under the direction of God, an almighty, all-powerful God who told us what he did. Is he powerful enough to tell us the truth? I think so. So there are several Bible-believing scientists, professional credentialed scientists, who believe that the stretching out of the heavens is the key to how the light could have arrived on day 4 in a young Earth model involving gravitational time dilation. There are several models, the main ones I'm going to be referring to, that depend upon gravitational time dilation. They all depend on the two biblical ideas that the heavens were stretched out and that light arrived on day 4. Russell Humphreys is an amazing man. I had the privilege of having lunch with him at the International Conference on Creationism. He's a highly credentialed physicist, used to work for NASA, and some of his work was classified, so if he told you about it, he'd have to kill you. But Dr. Humphreys has got a model that I'm going to go into a little bit of detail on the next few slides, and he would never claim that this is proven. It was just an introduction to the idea of gravitational time dilation. Also, Dr. John Hartnett has a book called Starlight, Time, and the New Physics. He builds on mathematics established by Moshe Carmeli. His work is found in Cosmological Relativity, the special and general theories for the structure of the universe. So I've mentioned before, I think, that some models rely upon dark energy and dark matter. Well, Dr. Hartnett's model points out that you don't need either one. And then Jason Lisle is the author of Taking Back Astronomy, and he's a fairly prolific speaker. His model includes the anisotropic synchrony convention, which is a special case of special relativity, special. But he believes, as the other ones, that there was a period when time in the outer regions of space passed extremely rapidly. And this is where he may differ a little bit from others. He believes that that period of rapid time only lasted as long as it took for God to expand the universe. So he does believe that we're now seeing stars in real time. That is, we're not seeing them as they were billions of years ago, but just in a fairly recent time period. I'm not going to tell you any of these are right, but I want to put them out there for your consideration. And if you read the books, Russell Humphreys' model is seen in the book Starlight and Time. All of the models that I referred to depend upon gravitational time dilation. That is, time can stretch out depending on gravity. This is certainly foreign to our everyday experience, but it's been confirmed by spacecraft. For instance, the GPS satellites in orbit, we take advantage of the fact that time moves a little slower for them. The farther away something gets from the center of gravity, the faster time runs. Low position, slow time. High position, high passage of time. So, in the beginning, God created the heaven and the earth was without form and void, and darkness was upon the face of the deep. And the Spirit of God moved upon the face of the waters. That's from Genesis chapter 1. That would imply that even before light, God created a ball of liquid water. Well, how big a ball? We tend to think of the earth with its oceans as being pretty big. Well, now I want to refer you to Dr. Humphreys' book, Starlight and Time. He believes that the ball of water was the raw material for the whole universe. How could you have that much water? Well, you know, the Bible says, praise the Lord, ye waters that are above the heavens. And the scientists have recently confirmed, at least to the extent they can with current technology, that there's at least one reservoir in space. This was in Astrophysical Review Letters in 2011. It talks about there's one single reservoir that contains at least 140,000 trillion times the amount of water in all of the Earth's oceans. That's 140 quadrillion times. The oceans have a lot of water, but that's nothing compared to this. So the scientists believe they've discovered this enormous reservoir. That's one reservoir. Is that the only one out in space? I doubt it, because the Bible says that God created a ball of water, the face of the deep. Spirit of God moved upon the face of the waters. So Dr. Humphreys believes that God started with an enormous ball of water. We'll get to the details of that pretty shortly. But then when he expanded it outward, when he separated the waters above the firmament, it really should be translated as expanse. When he separated the waters above, it would be moving away from the center of gravity. While the time passage near the center of gravity is relatively slow, low equals slow, but if the Earth was near the center of gravity or at the center of gravity of the ball of water, then the time passage in the parts that were being pulled out would be much, much, much faster. How many times faster? So much so that, we could have had millions of years of space-time elapsed during one day of Earth time. The more mass and the greater the distance it was moved from the center, the greater the gravitational potential energy. And the greater the gravitational potential energy, the greater the passage of time. Time at the center would be barely affected, if at all. So time dilation certainly requires that the universe has to have a center of gravity to point toward. And those that follow of Big Bang in 4 dimensions have to say there is no center of gravity. Well, that's a theoretical construct to get rid of the apparent position that the Earth is near the center of the universe. So is the Earth near the center? Is it in some sort of a special place? When we look around the universe on a large enough scale, we see that the distribution of matter, galaxies, galaxy clusters, quasars, just about any other type of heavenly body, it seems fairly even in every direction. It looks like we're fairly close to the center. Likewise, when we compare the distribution of redshifts, which we'll get back to shortly, from the distant stars and galaxies, it seems to indicate that we're fairly close to the center. Now remember, the Big Bang says, no, there's no such thing as a special place. The Big Bang is ultimately an attempt to get rid of God. But if there is a preferred frame of reference in the universe, then, the Earth may be in a special place. Then how can we tell if the universe has a center? Let's revert back to the concept of redshifts. The light from the distant objects would naturally have a certain spectrum of colors in it. If you look at the one that says normal absorption spectrum, hydrogen has been examined for at least 150 years under laboratory conditions, and it always emits certain colors or absorbs certain colors depending upon the circumstances, but the colors are the same. So the reports of the universe expanding are based on the colors of light from stars that are shifted toward the red end of the spectrum. If you take some hydrogen and begin to move it away from you as it's emitting light, the spectrum is going to shift. It's going to stretch out toward the red end of the spectrum. If it's moving toward you, it's going to shift toward the blue end of the spectrum. The vast majority of what we see coming in from space is redshifted. That indicates that whatever is emitting that light, the stars and quasars and so forth, is moving away from us. So we can't determine the exact amount of time it took for the distant heavenly bodies to reach their present position, but we can be confident that the red shifted light coming from most of them indicates that there is relative motion. They're moving away from us, or you could say we're moving away from them, but as long as there's relative motion, they're getting farther away. And the farther they are, we've noticed that the greater the amount of red shifts. There are few things out in space that have a blue shift, but the vast majority are red shifted, indicating they're moving away from us or we're moving away from them. So if we work backwards through time, we can see there had to be a time where they were the closest to us that they've ever been. And many Christians believe this corresponds to the time when God began to spread out the heavens. So let me refresh your memory a little bit. We've talked about this before. If the universe was expanding uniformly through three-dimensional space, an observer that's not near the center would see all varying amounts of red shifts, a continuous range that was determined by the distance of each object or galaxy emitting light. And about 2 million light years from the center, the distribution of red shifts should look something like what you see below, just a shotgun approach, scattered all over the place, varying amounts of red shifts. But if there was an observer fairly near the center of the universe, that observer would see red shifts in discrete intervals. In shells, the distribution would look something like what you see in that graph, distance in millions of light years. Well, which one do we see? We see the one toward the right, the one that would indicate that, oh, the Earth could be near the center of the universe. So we look in space, we see roughly the same number of quasars and stars and galaxies in every direction, and we look at the redshift and we say, oh, it's pretty much the same in every direction. That really, really, really suggests that perhaps the Earth is near the center of the universe. Okay, now, if you believe in the Big Bang, then you say there is no center of the universe. This would depend upon something called unbounded space, used by the Big Bang. No center of the universe, because the universe is actually four-dimensional. What is the center of four-dimensional space? We have no idea. But let's bring it down to 3 dimensions just to help us understand. Suppose there's a flat ant, a 2-dimensional ant. He's confined to the surface of a sphere, like a balloon or a globe or something like that. So all he can do is walk along the surface. Could he ever reach the center? No. From his perspective, there is no center. He's confined to the surface. Could he ever reach the edge? No. From his perspective, he's confined to the surface. So to that ant, that 2-dimensional ant, space is unbounded. Now, if space is a 4-dimensional hypersphere, as a lot of Big Bang models say, then we're confined to the 3-dimensional surface of a 4-dimensional hypersphere. What? Well, this is the proposal for the Big Bang. You can never find the edge, you can never find the center, because neither one exists. If you shoot a laser beam forward and you wait long enough, eventually it's going to come around and hit you in the back of the head. 4-dimensional space would have to be unbounded. And so this has to do with where the center is, if there is a center. It's called the cosmological principle, or the Copernican principle. So our 2-dimensional ant is confined to the surface of this sphere. No matter where the ant goes, things are going to look pretty much the same in any direction. That is, there's no preferred frame of reference. Likewise, Big Bang models assume that no matter where we go in space, things on a large enough scale will look pretty much the same in any direction. Can you prove that to me? Can you give me any physical evidence? Can you give me any sort of test? No, that's philosophy, not science. If there is a preferred frame of reference, then the Big Bang's wrong. And at least some of the assumptions of relativity are wrong, that there is no preferred frame of reference. So is the Earth in a special place? Well, when we look around the universe, we see that the redshifts point to the conclusion that we're fairly close to the center, but also distribution of matter, galaxies, and so forth seems fairly even in every direction. That would seem to imply that we're fairly close to the center. According to Big Bang models, that's an illusion. The universe has no center. There's no preferred frame of reference. The Bible makes it plain that the earth is a special place. This is where God started his process of creation, and this is where Jesus is returning. The Creator is coming back to the center of his creation. And when he does, it's not just going to be a little local phenomenon. The whole universe is going to be affected. The heavens will be dissolved with a roar, and the elements will melt with fervent heat. The heavens will be rolled up like a scroll, and so forth. So look in Revelation and Matthew and Isaiah and 2 Peter. So time is going to behave very differently in some places than in others. For this, we need to understand, or at least be familiar with, the effect of gravity on time. You've probably heard of black holes. A black hole is a theoretical concentration of mass that's so great, not even light can escape its gravitational pull. So there's, around the outer edge, there's going to be something called an event horizon. The force of gravity drops off by the square of the distance from an object, so there's a radius called the event horizon, outside of which light won't be drawn in, but inside even light can't escape. So there has been a lot of information about time near and inside the event horizon. Remember, if something is close to the center of mass, if it has a lower gravitational potential energy, lower equals slower. Inside, time is going to pass slower. Outside, time is going to pass faster. So if light gets sucked in, if it crosses the event horizon, it's never coming back out again. So Dr. Humphreys has written a model. He's written a book called Starlight and Time. And there's a contrast between what he says versus the Big Bang. The Big Bang says that there was some unknown forces that caused the explosion to happen. We don't know what they were. Well, in Humphreys' model, some unknown force, presumably under the direction of God, began to make the ball of water expand. So the Big Bang says that there are 4 dimensions of space and 1 of time. Space exists only when matter and energy are present. Humphreys says no, the universe has 3 dimensions of space as well as 1 of time. Space is there whether matter or energy are there or not. Now it can be altered, it can be stretched, but it's still going to be there. The Big Bang says the earliest matter was in the form of hydrogen. Humphreys says the earliest matter was water, which is hydrogen and oxygen. The Big Bang says all matter was concentrated in an almost infinitely dense point, whatever almost infinitely means, known as a singularity, but Dr. Humphreys' model says all matter was concentrated in a sphere of ordinary water that had a diameter of up to 2 light years. Well, Big Bang says the expansion began 7.5 to 15 billion years ago. It's still going on today. Wow. In Dr. Humphreys' model, the expansion began on day 2 when God separated the waters above the firmament from the waters below. And Big Bang says the universe is expanding faster and faster and faster. Humphreys' model says, no, most of the expansion was complete by the end of the creation week. And the redshift we see is a residual effect of that expansion. Big Bang says space is unbounded. There's no center and no edge. Earth has no special status. Well, Dr. Humphreys says now space has a definite center and edge, and Earth started very close to the center, maybe not exactly at it, maybe exactly at it, but the Earth is probably still close to the center. Big Bang says there's no center, since it's four-dimensional, there's no center for gravity to point toward. So the universe has never been in a black hole. A black hole requires gravity pointing somewhere. And Dr. Humphrey says, no, there is a center. The universe began in a black hole. And then God changed it to a white hole on day 2 of the creation week. White hole. That would be where some unknown force, which I would presume would be the direct intervention of God, a non-natural process that began to make the matter expand outward into three-dimensional space. So the Big Bang says the heavenly bodies formed as clouds of gas and dust came together by gravity. Dr. Humphreys appeals to the book of Genesis that says God started with a ball of water. He believes that the expanding waters furnished the raw materials for what was going to become all of the heavenly bodies. As you can see, there's a great deal more to this than what I've been covering. People will devote their entire careers toward figuring out things about gravitational time dilation and so forth. But we're going to try to finish up with this topic as well as we can. So if you want more detail, by all means, go out and read the books from Dr. Humphreys, from Jason Lisle, from Dr. Hartnett, and don't stop there. Just keep on going and going and going. But in the next session, we'll get into a little bit of the details of how Dr. Humphreys' work might have operated, about how his model might apply to the universe. So stay tuned, come back for the next episode.